The basis for all of calculus has to do with limits, so we need to be able to evaluate a limit. The easiest approach is called direct substitution. All we have to do is substitute the value that x is approaching to see if you get a real number. Let's look at an example here. Since x is approaching the value of 2, we replace x with a 2 and see what the answer is. So we have 2 times 4 minus 12 plus 1, 8 minus 12 plus 1, minus 4 plus 1 equals negative 3. So the limit approaches negative 3. If we look at a graph, here's the graph of y equals 2x squared minus 6x plus 1. As x approaches 2, the y value approaches negative 3. So that makes sense. A second technique is called dividing out technique, where if it turns out that you have a fraction and numerator and denominator have a common factor that will cancel, this will help out. So let's take the example, the limit of x squared minus 4 divided by x minus 2 as x approaches 2. Notice we can factor the numerator as x minus 2 times x plus 2, and the denominator is x minus 2. We have a common binomial factor of x minus 2, so the answer is x plus 2. So we simply have to graph the line y equals x plus 2, except for the fact that notice there's a hole where x equals 2. And the reason for this, once again, if you take the denominator, x minus 2, you set that equal to 0. Notice x equal to 2, so x cannot have a value of 2. So that's a restriction. Finally, we have a rationalizing technique. And when you have complicated square roots, this is a very nice technique. Please notice that you can use either the numerator or denominator to work with. In this particular example, the square root of x plus delta x minus the square root of x over delta x, notice the radical is in the numerator. So let's multiply by the conjugate of this, which will be the square root of x plus delta x plus the square root of x. And let's multiply both the numerator and denominator by this. And notice we'll simplify the values up top because that's where we need to take care of some problems. Notice this is minus and this is plus, so we only wind up with x plus delta x. The two middle terms drop out and we're left with minus x all over. Now the denominator, there's no advantage in multiplying through, so let's just leave it in this sloppy form and pray that something nice will happen as we continue. Notice the x and the minus x cancel out, so we're now left with delta x in the numerator over delta x times the square root of x plus delta x plus the square root of x in the denominator. Now these cancel out, so we're left with a 1 over this value. Now, since we're taking the limit, let's go back to the direct substitution. If we replace delta x with a value of 0, we now have 1 over the square root of x plus the square root of x, since this is 0. But these two are both the same type of radical. They have the same index of 2, and they both have x as the radicand. Therefore, the final answer would be 1 over 2 times the square root of x. And these are three methods that we can use in evaluating a limit.